The b value is the number in front of x. So we plug that in. I got negative 7 over 2a, which is 1. And then I simplify, that's just negative 7 halves, or I even prefer a decimal, negative 3.5. You guys okay with that? So that's my axis of symmetry. So I'm going to graph that. I'm going to count over 1, 2, 3.5. And now I have a little vertical line going up and down at x equals negative 3.5. Okay? Now I should know that I have a vertex that lies on that line, right? So I know I have a vertex, and that's at negative 3.5 comma something. So I've got to find that something, and this is where I could plug it in by hand. But you guys, I mean, you're busy, right? You guys got English papers to write, and what else? Psych papers to write. I would say you'd have a hot date, but it's Corona time, right? You shouldn't be smooching or going out with anybody right now, right? All right, so let's just get this done quick, right? So this is where we grab our calculator, okay? Oop. Now, from time to time, when you guys are graphing, you guys still have your plots on from the last section. So you want to make sure that you go up there to plot 1 and press enter and turn that plot off. You only use those plots if you're doing the scattered diagram stuff, okay? If you get an error and it's a dim mismatch, your dimension mismatch error, that's usually because you have your plots on. So make sure those are off. All you got to do is press enter, turns them on, press enter, turns them off. All right, I'm going to graph my equation. I've got x squared, so x squared plus 7x plus 12. And I'm going to go zoom 6. Zoom standard, zoom 6. I'm going to graph it. There's my pretty looking graph. And now I want to find this vertex, which is again on my axis of symmetry. So all I got to do, second trace, value, and now this allows me to plug in any x value I want. I want to plug in this guy right here. I want to plug in negative 3.5, press enter, does it all for me. I got negative 0.25. Okay, so negative 0.25 is like a fourth of a box down. Just put a little dot there. Okay. Now, I could use the pattern of a quadratic. I could go over 1, up 1, over 1, up 1, but that's too many decimals. And anyways, so what I would do is I would just use my calculator, okay? If I'm at negative 3.5, let's plug in a nice, pretty integer. And I got a sneeze coming here, guys. I'm trying to hold it off here. I'll leave my mask on. All right, I got to plug in an integer. What's a nice, pretty integer from negative 3.5? What's the one just to the right of it? Negative 3. If I plug in negative 3, I get 0. Look at that. That's an easy point. So negative 3, 0. And if you did negative 4, it's symmetric. You would get 0. So negative 4 is 0. So I did negative 3. The next one would be like negative 2, right? So plug in negative 2. And I get 2, so over 2 up 1, 2. So from the origin, if I did negative 5, I would get 2 as well. Okay, so I've got enough to graph it. Just a rough sketch. Okay, so just because it's got a decimal doesn't mean you can't do it. It's not too bad. Okay, but from there I would graph other points that are nice, pretty integers. Just use your, you can use your table, second graph, or I like second trace value. That allows me to plug in any value I want. Okay. You guys have any questions? Any questions at all? All right, let's do the last one, number 9, and then we'll do 10. Okay. So we got 2 more. 2 more. So number 9, I've got g of x equals negative 3x squared minus 6. Okay, the first thing I always like to refresh your memories on is the a value. Remember that a value is the number in front, okay? And that a value tells me a lot about this quadratic, all right? If it's a positive, then it's a smiley face. And if it's a negative, like this one, I know it's a frowny face. Okay, so that A value is the same A value that is in front of the transformational form. Same thing, same one. Okay, that does the exact same thing. So I know because it's -3, I know this is a frowny face, and I know it's getting stretched by a factor of 3 vertically. Okay. All right. Now, again, I don't want to complete the square. Plus, I've never shown you how to complete the square when there's a number there. So we're not going to do that. We're going to do this. We're going to do x equals -b over 2a. So we know a, and b is that -6. So we're going to plug in a negative -6, and then 2 times -3. Negative times the negative is a +6, and 2 times -3 is -6. Final answer for my axis symmetry, I got x equals -1. You guys okay with that? Okay. So I'm going to graph that. So there's that axis sem, and now I need my vertex. I know it's at -1 something. Okay, so it's somewhere on this line. I got to find it. So I could just plug in -1. I could plug that -1 in here and here by hand, but I don't want to do that. Just throw it in my calculator. That's why we spent all this money on this thing. We should know how to use it. So I plug it in. Now this is the time for -3. This is the time where I would use this negative. Okay, this is the only time I use this little negative. So -3 x squared. And now between terms, I got to use the big minus sign. Okay, so minus 6x. So I've got -3x squared minus 6x. I'm in zoom 6. I want to graph it. And I've got my nice, pretty graph. Okay. I want to find the top of that mountain. I want to find that maximum. So I go second trace value, and I'm going to plug in my axis of symmetry, -1. And I got 3. Are you guys getting that? You guys okay? All right. So I'm going to graph that. I'm going to go up 1, 2, 3, and there's my vertex. Okay. Now you can use your graphing calculator to find more points, or if you know what's going on with the pattern, if you know I normally go over 1, up 1, over 1, down 1, and I have an A value of -3, here's the idea. Now it's over 1 down because it's negative. 1 times 3, so over 1 down 3, over 1 down 3. Okay. Normally the pattern is over 2 boxes, up 4 boxes, right? Well, now it's over 2 down because it's negative. 4 times 3, it's getting stretched. So 4 times 3 is 12. So I'm going to go over 2 down 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right there. And it's symmetric. And then I got a nice graph. There's my parabola. Okay. Now, do you have to do that if you don't know the pattern? Well, then use your x values. So I'm at -1, the next integer, second trace value, the next integer I would do is 0. I got 0, 0, that's this guy. Symmetric, so I got -2, 0 as well. After 0, the next integer is 1. So I just plug in 1. That gives me -9, that's this guy right here. Or I can plug in -2. That's -9 as well. Oh, -3. That's -9 as well, right there. Okay. So you got different ways to find those other missing points. You can just follow the pattern of a quadratic. Just watch out for your A value because that's a stretch or a reflection in a stretch in this case. Okay. And that's it, guys. That's how to graph using an axis of symmetry formula. The last thing I always like touching on before we move on to the last one is domain and range. Domain for quadratics are always the same thing. Always, always, always. What's the domain? Jake? Yeah, we got -infinity to +infinity. Fantastic. Okay. Good job, Jake. And then range is always bottoms up. How low does it go? Does it go down low, down to the flow? For show. Goes all the way down here to negative infinity. How high does it go? Does it go up high all the way to the sky? It stops right here at this y value. What's this y value? 3. It's a solid dot bracket. Yeah, buddy. All right. So that one's done, right? Good stuff. People online, people in class, you guys got questions? All right. Let's do the last one. So now this is kind of like working backwards. All right, this is going back to transformational form. I've got y equals a times the quantity x minus h squared plus k, and we're trying to come up with that equation. And they're going to give us some information about this graph. They're going to give us, in this case, they gave us the vertex and then a point or a coordinate point on the graph. And what we need to do is we need to come up with a number for a. We got to come up with a number for h and k. All right. All right, so given the vertex and a point, what did they give us so far? What do we know? So this is where you guys online turn your mics on and answer the question if you know it. Don't be shy. This is brainstorming 101, pre-calc style. Do I know A, do I know H, or do I know K? Or do I know a lot of those? Jake says H and K. Why H and K? What's H and K? Yeah, this guy right here, right? Awesome. Our vertex is H and K, right? So we know this is H and we know this is K. All right, so right now this is where I'm at. I've got y equals A. I've got x minus h is 2 squared plus k is 13. So that's what I'm at right now. The problem that we have really is we don't know A. This is the guy we don't know. We need to find A. Okay? Well, the only other information they gave us is this guy. This is 4, 1. It's a coordinate point on a graph. Now, normally, what does coordinate points represent? What letters? X and Y. Perfect. So this is X and this is Y, right? Plug it in, plug it in. So I plug in, I've got 1 equals A. X we got is 4 minus 2 squared plus 13. Here's the big idea, guys. On this equation, it's 1, 2, 3, 4, 5 variables. And they gave you 4 out of the 5, right? If they had 2 variables and they gave you 1, you can find the other one. If you have 3 variables and they gave you 2, you can find the other one, right? Same idea. If they got 5 variables and they gave you 4 things, plug them in, find the last one, okay? All right, so I simplify. Please excuse my dear Aunt Sally. Do our parentheses first. 4 minus 2 is 2 squared. Then we do our exponents. That's 4a plus 13. And then we finish up a little algebra for all you playing at home. 1 minus 13 is negative 12. Divide, and we should get a is a negative, which is good because it's going down. I got a was negative 3. Okay, final answer. Plug that back in. So I've got y equals, a is negative 3, x is x, h is negative 2, so x minus 2, and then squared plus 13. Final answer, boom, done. Okay? So again, the big idea is they really give you the 4 out of the 5 things. Plug those all in to find the missing a value. Okay? Or if you can tell that it's over 2 down 12, normally it's over 2 up 4, right? Now we're going down because it's negative and it's been multiplied by 3. Okay, so if you can see that visually, then you can just do that. Okay? So, ladies and gentlemen, I am officially done with chapter 3.3, day 1 notes. Okay? We have more stuff to do for tomorrow.